Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
All right, greetings everyone, and welcome back to another exciting episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, well, we're moving on with more in our A-plus series, the 22902. They got too many twos, too many nines, and too many zeros in that thing for me, but it is a lot of fun to say. And joining us in the studio to help me figure that out is our good friend, Mr. Wes Bryan. Wes, welcome back, man. How's it going today?
I'm over here dying, man. That's awesome. I mean, out of like 60 episodes we've recorded,
I finally get it wrong.
I was going to say, I think you've only missed the curveball maybe once.
I've been
maybe
wanting
twice.
to call that thing the 920 for like 2 weeks now. I don't know why.
That's right. And as you can see, that's right. We're back in A+, right? It just happens to be the 902, and we are going to be looking at something that's kind of interesting, and it might throw you off a little bit when we talk about network host services. Dan and I were actually talking and discussing this before we even started, because we've been into things like system administration. I can say
Max
aluminum too. You're rubbing off on me, Dan. That's for sure.
You minimum.
That's right. So you might be looking at this episode title and saying, well, what the heck are we talking about? And the reason I say that is because in systems administration and networking, we talk a lot about the services that different computers provide out on our networks. And while most of your computers are networked hosts, we got to understand what a host means, right? In the earlier days of computing, a host really just meant something like basically a centralized mainframe, right? It hosted all the services, provided all the resources, all the storage, all the processing power that you can have on your networks. Well, that really isn't the case anymore today. When we talk about generically TCP/IP-based networks, a host is really nothing more than any self-sufficient computer operating system device that can manage and maintain its own networking communications out there on the network today. So when we talk about network host services, what are we talking about? All right, I want you to think of them about the services and resources that are provided to other computers out there on the network, right? In past episodes, we've talked a little bit about our network architectures, right? Network technologies. We've talked about what a client is. We've talked about what a server is. We've talked about peer-to-peer environments, right? So let's go ahead, before we dive into the different services that we have out there on our networks, let's talk about the networking models, if you will. Remember that we have a completely decentralized networking model, and that's a peer-to-peer environment. They call it a peer-to-peer environment because each one of the operating systems or the devices that are associated with the operating systems out there can act like a client requesting a resource as well as providing resources on the network. So for instance, in Microsoft Workgroup is essentially Microsoft's implementation of a peer-to-peer network. I can have one computer that actually has a printer connected to it, and that printer, if you will, is basically going to be the printer that everybody else uses on that network. Well, that computer is acting kind of like a server. It's providing a service, a print functionality for the rest of the network. While on another computer, we could have maybe Dan's put about 10 hard drives in it, so we know there's a lot of storage in that one computer within this peer-to-peer environment. So guess what? That device is where we're going to store the majority of our business documents in a SOHO, right? Maybe we've got a RAID array in there, a RAID 1 configuration, so we got a little bit of fault tolerance redundancy so that if one of the hard drives fails. So you can see that those two computers are providing resources. But when the computer that is actually in that peer-to-peer network that is providing the storage for our files needs to send something to a printer, well, now it's no longer acting like a server, right? It's going to request a resource that's provided by the other computer. So that's why they call them peers, right? And peers are in relation to another type of topology or architecture called client-server model. And client-server models where we get into our corporate environments, right? Client-server models where we get centralized administration. Rather than in a work group, we call it decentralized because you have to go from computer to computer to computer managing user accounts and resources, and every computer controls its own resources and user accounts. In the client-server model, we have centralized administration because we can use things like authentication servers, right? When we use an authentication server, essentially what we have is a single server out there that's on the network, and what it does is it really provides the authentication resources for all the other machines that are out there on the network, right? So for instance, we could have like an Active Directory domain. If we talk about an Active Directory domain, then essentially what we mean here is that we have one single device, one single computer that's out there on the network that when somebody logs in, In fact, let me show you here. I got a little diagram here. So when somebody logs into the network, right, rather than that being checked on the local machine, that authentication, it actually sends it out over there across the network, right? And the user database is stored on the server, right? So now we're talking, when we talk about client-server model, what you have are clients, all right, that are, you can do most of your day-to-day functionality, right, but they do require a certain amount of resources or services that are provided by other computers out there. And that's where the server comes in. Keep in mind, in this case, a server, right, is denoted by the role or the service that it's providing. In this case, it happens to be an authentication server, which means when the client, you log on to the client, right? Dan or I, we log into our local computer here. Well, it really isn't the computer that we're logging into that is providing the authentication. What it's doing is it's calling out to the network. Again, a client requesting resources out there saying, hey, somebody out there on the network, do you have a database that has Dan and my username and password stored in it? Because we need to I need to see if I can grant access to this device based on that service. So again, keep in mind that client-server model means a client requests the resources and the servers provide the resources. So when we talk about network hosts, kind of back to the original point here, when we talk about network host services, all right, I want you to think about services that we're going to talk about. It's more about the servers providing a service, providing a role, a functionality that's needed, typically in things like corporate environments. Now, it doesn't have to be a corporate environment because you can have things like media servers out there on a SOHO environment. But again, due to sometimes, or you could even have a local web server on the local environment. But either way, keep in mind that we typically find these in an enterprise level network. So in this case, an authentication server essentially has a database, right? Just a little bit of storage on the hard drive, right? And it contains all of the user accounts for every user within the network. And the good thing about this is when we say centralized management, it means that if we have multiple clients out there on this type of network, then a user should, in theory, be able to log in to any one of those client computers, because since the client computer is just going to hand off the authentication to a server that's providing that service, we don't need to manage and maintain it decentralized like we would at a peer-to-peer group. So that's a little bit about your authentication server and a little bit about where we're going when we say services that are being provided. I want you to think of the service as the role or functionality that is being performed by something that's really nothing more than a computer, right? Remember, a computer is typically defined by the operating system that is running on it and the functionality that it plays within your network. Now that's one of the major servers that we have is an authentication server providing an authentication services, but we also have things like DNS services, right, that are needed, are required to do name resolution. We've talked pretty extensively about the DNS service in another episode, I believe it was the 901 episode, where we had to go through the protocols to kind of understand how the networks were communicating with one another. Well, remember, one of the two major services that are out there on your network are DNS and DHCP, and we'll talk about briefly.
So it's completely unimportant.
Yes, yeah, that's right.
Don't worry about it.
We're never going to need it at all. That's right. Because think about it, you don't really know a lot of the IP addresses to the computers that you are trying to communicate with. In fact, let's take the authentication server. In fact, let me kind of just backstep here a little bit, right? An authentication server, it really a lot of times is not a client reaching out to the network and saying, hey, who's got 10.10.10.100? It doesn't say that at all. In fact, it says, hey, I need this service out here. I need this authentication service. In this case, I need to talk to an LDAP server, right? Well, to be able to find that service that's being provided, guess what it does? It relies on DNS. First, it talks to another server and it says, hey, you got a name here? Because all I have is a name and I need an IP address. And in this network protocol stack that we have, it's telling me, according to the rules of TCP/IP, I got to have some kind of number to talk to this authentication server. So you can start to see that these services that we have out there, and again they call it network host services, these roles, these functionalities that are out there allow your computers, if you will, to communicate between one another. DNS, keep in mind, takes names and it resolves them to IP addresses. It's why we could type into things like our web browsers, right? We type into our web browsers www.google.com, www.yourcompany.com, and we can go to the web servers and we can actually find them. Which brings me, well, to the web server, right? So what is a web server doing for us? Well, I want you to think about a language called HTML, right? That's the hypertext markup language, right? Hypertext markup language is essentially the language that a web page is written in. And what we use a web server for, right? Well, it's a combination of things, right? We have a web application, and then we have a web application server. So in this case, you're probably familiar with a lot of the different web browsers we have, which is your web application, right? And the web application actually is the software that acts like a client. And what happens is when you browse with DNS, it renders the IP address, or resolves, if you will, that name to that IP address. Now your web application, your browser says, oh, now I know where the IP address is of this web server. Let me go ahead and I'm going to reach out across the network. You can start to see how they're all kind of intertwined here, right? I can reach out to the web server, and what you're actually going to do, and I say you guys, keep in mind it's the software in the background that's doing this, is the web browser is saying, hey, I need that web page. Do you have that web page? Right? And over something known as HTTP is the communication protocol that's happening, right? Hypertext Transfer Protocol. We actually reach out to the web server and we request a resource. Now, as you go on into networking and then, or Network Plus, maybe you go on to Security Plus, where we start doing things like firing up packet analyzers, right? Protocol analyzers. You can actually see this communication going on. You're reaching out, you're saying, hey, give me, it's actually a GET request, but you're saying, hey, give me this resource. Do you have it? And then the web server, based on permissions, based on your authentication, sometimes we secure them so just not everybody can communicate with the web server, says, yeah, let me look down on my hard drive here. All right, I see that HTML, that web page that you're requesting, and it returns it back to the browser. And then over HTTP or HTTPS, right, Hypertext Transfer Protocol or Hypertext Transfer Protocol over Secure Socket Layer, right, it's going to be HTTPS is secure. It delivers it to the web browser, and then the web browser's job is to take the HTML and render it. And guess what? We see the web page. A lot of things are going on in the background, right? A lot of interconnections, a lot of communications between each other, between client and server have to happen just for your average everyday computing experience. Now, I mentioned DHCP. All right, we've also talked about DHCP in other episodes here too, so I'm just going to briefly kind of recap, right? So if we're talking about something like, right, DNS, all right, what's happening, right? DNS, again, you're calling out and saying, hey, I got a name, you got the IP address so that I can view this, I can talk to this computer. Well, DHCP remembers the Dynamic Host Configuration Protocol. And what actually happens here is your computer connects to the local network and it doesn't have an IP address. So what does it do? It yells out to every computer on the network, everybody, and says, hey, anybody out there got an IP address? I could really use one. I'd like to talk on this network. All right, that's called a discovery packet. All right, so your client is requesting a resource. In this case, it just happens to be some host configuration, and there's a server out there that's listening, the DHCP server. Now, please understand that we're also talking about software here, so even though, as far as the diagram goes, I've got like this big, massive server here compared to this client, it could just be your access point. If you're on a home environment, it could just be a wireless access point that's running the DHCP service, right? That's still gonna provide that service, or that it is the server serving up that resource. And then what happens after that? Well, in DHCP, keep in mind that what the server is going to do is it's going to offer some host configuration. It's going to say, hey, I've got this configuration package for you if you want to accept it. And then the next process is the request. It's my computer saying, yeah, that sounds good. I'll go ahead and I'll take those configurations, that IP address, that subnet mask, that default gateway, some other options like which DNS server you're going to use when you need to use name resolution. So it makes a request. So we've got discover, offer, and request, right? Last part of this is, remember, the DHCP server makes an acknowledgement and says, okay, let me just go ahead and mark this down in my little database so I know that you're going to take this IP address, it's going to be valid for this length of time, so that I don't give it to somebody else. So that's your DHCP server as well. All right, so that moving on, we also have many different types of mail servers, right? And when we say mail servers, what we're talking about is your email servers. We've talked about some of the different email protocols in other episodes as well. Keep in mind that one of the email protocols that we've talked about is SMTP. All right, when we talk about SMTP, or the Simple Mail Transfer Protocol, what we're talking about is sending information. Now, this is a request, if you will, kind of, because what's going to happen on your local network? Okay, so let's go back to some of the other servers that we've talked about. First you authenticated, you logged into the computer, it sent the authentication out to another computer, right? It validated it. Hopefully you can log in. If you're like Wes, you might have to type the password a couple times before you can get that right. But then you need to send an email. So what happens? You're going to reach out to DNS again, and you're going to say, hey, I've got this name, smtp.demo.itpro.tv. Well, where the heck do I find that server? And DNS returns the name. All right. And then if we could show you the little diagram here, what ends up happening is your computer sends that email out to the SMTP server. Remember, like we've talked about in other episodes, SMTP is to forward email. So you're actually sending email. We got some other ones out there too, so we'll just kind of go over each of them because they do mention mail server, but mail server is a mail server. It really just depends on the direction and how you utilize it. Protocols differ a little bit. All right. Notice the direction of the communication on this one when we talk about a POP3 server, Post Office Protocol version 3. When we say POP, we're pulling email, right? You have push and pull, if you will. Pushing email is forwarding it, sending it outbound. You might see that as you go into like networking when they say, hey, we pushed a configuration out to the switch. That means you're sending it outbound, right? If you're pulling something down to a machine, right? In this case, we're downloading, right? We're downloading our email to our local inbox. Now, remember that POP3, there is a limitation to POP3 in the fact that when you download that email, it erases it off the server, which means that if you go to another computer and you log in and try to find your emails, sorry, it's actually on the other computer that you downloaded it to, which brings us to our last email type server, mail server that we would have, and that's IMAP. Right? Remember IMAP, Internet Mail Message, or Mail Access Protocol. I've heard them call it a couple different things. Internet Mail Access Protocol or Message Access Protocol is another one that allows you to manage your emails up on the server. All right, so that's got some of the major ones. Another one that we talk about in another episode that I'm going to kind of brief over. In fact, Dan reminded me that we talked pretty extensively in another episode when we were talking about printers. In our, in networking devices and stuff together, we've talked about a print server. All right, keep in mind that a print server is nothing more than the software that is managing the print queue, really. Windows machines, they have the ability to become a print server. We have the print management functionality built into the administrative tools within every client operating system. It essentially means that Microsoft gave you the ability that whether you're in a client server network or you're in a peer-to-peer network, your Windows client operating system can act as a print server. And when we talk about that, keep in mind that a print server, what you're doing is it's receiving, right? So we talk about, again, requesting services and providing services. If I send a print job over the network, right, something that I have to print over to another computer, I'm acting as a client. And that service that's being provided, that, hey, yeah, you can send it to me, and I'll manage that print queue, and I'll send it to the right printer, is the print server. All right, so that's essentially what a print server is. Don't think of it, again, as having to be this really beefy computer. I know, Dan, I don't know about you, but I've seen some print servers that were the size of a Roku sitting out on your network, and all they were doing was just managing the print queue.
Or you have them just built into the device itself. They'll have print services. Just you go to a little LCD display screen, you start bumping through the menus, and it says, would you like to make this a print server? Well, yes, I would. Thank you very much. Turn that on, and there you go. They're doing that more and more anymore, right?
Most definitely, especially on like you get smaller networks like Soho networks like that. And you get things like wireless communications, right? You're finding that built into a lot of devices, you know, where they're doing AirPrint or AirPrint, like in Mac-based devices and stuff like that. Wi-Fi direct type printing as well. So again, keep in mind that while we are talking a lot about the corporate environment, it's just as valid, especially when it comes to printing in Soho environments or work groups. All right, so that's a little bit about your mail servers as well, and print servers too. Keep in mind that we do have some other type of servers that we need to be aware of too, and these sometimes can get a little confusing. These are proxies. All right, now we've talked about proxies before, and I got a little diagram to kind of understand what's going on with a proxy, and I kind of built this up as much as I could so you can really kind of, in a diagram, see what the heck is going on here when we talk about a proxy. Well, a proxy is kind of like a middleman, if you will, middle person, if you will, not to exclude our ladies out there, between a request being made and the offer coming back and returned to the client, right? One of the great things about a proxy is, okay, this one, and I'm just going to take forward proxy out of here. You guys do not have to know about the difference between a reverse and forward proxy here at the A+ level. We talk more about that in the Net Plus and certainly in Security Plus. But understand that the proxy, a lot of times in this case, is a web proxy. There are other services out there that can be proxied as well too. But by large here at A+, we're talking about a web proxy. And it just means that my client is going to make a web request, right? Just like browsing to the internet. But the difference here is, instead of the web browser sending that information out to, let's say, a website out there across the internet, what it does is it actually sends it to the proxy. All right, and then what the proxy does, well, a couple of things. Let's say the proxy, this is the first time it's received a web request for this website, www.anysite.org. If there's a site out there that is www.anysite.org, I apologize ahead of time. Just trying to generically make these up. Well, what it's going to do is, if it's never received a request for that website, is it's going to generate a completely new request, all right? And when it does, it's going to send it outbound through your network, and it's going to send it over to the website. Now, the website, understand that from this standpoint, doesn't know that this client at all sent the request. All the website knows is that it was the proxy that generated the web request, and it sends that web request back to the proxy. All right. Now, once the proxy receives it, it does a couple of things. All right. One of the things that it does is it caches, right? Just kind of like we talked about DNS cache. It caches on the local hard drive that web request, and then it sends it back to the original client. Now, let's stop right there and say, so you understand, what are the benefits of that? All right. Well, from a security standpoint, the proxy is the only thing that exists inside of your network, because when the web server received the request, it didn't receive it directly from the client. It only received it from the proxy. So everything behind, essentially, to your network, if you will, if I was to, let's just kind of say here, take this block, everything behind your network doesn't exist to that web server. And that's great for security purposes. If you want to try to keep people from easily seeing what's behind your network, it kind of obscures it. Now, the other great thing about this is on the proxy, you can control what sites can be seen. You can do things like content filtering, sometimes called URL filtering. You can base it on keywords and stuff. Certain websites shouldn't be viewed at work, right? And there's some that are obvious. But even things like online gambling and stuff, maybe you don't want people going to. Maybe you don't want your end users within your business chewing up your bandwidth by streaming Netflix, doing media streaming, you know. So you can control that, right? The other thing is you can control who has access, all right, as well. Now, the other great thing about this too is that let's say this next computer decides that it wants to communicate across the internet out here with www.anysite.org. So what does it do? Well, the second client actually makes a web request. It hits the proxy, and the proxy says, well, hold on a second. Let me check my cache here. Let me find out. Oh, you know what? The first client's already requested that, and it's still up to date. So instead of having to reach out across the internet to www.anysite.org, I'll just go ahead and give you that information from the cache. Now, how does that benefit you? Well, twofold. All right, and I'm sure there's probably more, but two that I can think of off the top of my head. One is that it increases the response time. I just had to find it locally. Two is it saves your bandwidth. If you've got some kind of metered connection like that, which typically your corporate companies will have some kind of metered connection like this, they save their bandwidth as well. So you also have the proxies too. So proxies are great. They're great from a security standpoint, you know, controlling who has access, as well as even giving you the ability to control how much bandwidth you're utilizing when it comes to multiple requests to the same site. All right. All right, Dan, let's see where we are here. I know we're running a little bit short on time here. We only got a couple more. The other one that I want to talk about is something known as an IDS. All right. These sometimes get a little confusing because there's what we call an IDS and there's what we call an IPS, right? An intrusion detection system and an intrusion prevention system. All right, so sorry to feed you alphabet soup right here at the end, but what are we talking about? Well, the intrusion detection system, I want you to understand, is really more of a passive device. All right, it sits out on your network and it does primarily three things. It monitors for signs of an intrusion, just like the name implies, intrusion detection. It detects, well, hopefully, that's the goal.
Yeah.
It detects and then it also sends out an alert, whether it be some kind of email or some kind of SMS message, right?
Yeah. Now, Wes, this is where a lot of people get confused because you said this was a passive technology, but it seems like it's doing something active. It is detecting network attacks and alerting to you too when they have occurred. So how is that passive?
That's
and
right.
Not active.
That's right, because the next one, the IPS, goes a little bit farther. Because one thing that the IDS lacks, really, in all actuality, the IPS does the exact same thing. But one thing that the IDS lacks is countermeasures. See, an IPS is called an intrusion prevention system, all right? And it does a lot the same thing, but see, the difference between the IDS is that is another device on our network where notice the IPS is screening all traffic coming in and leaving the network, and then on top of that, it provides not only monitoring and detection, here's where the active nature is, countermeasures. When I find out, or the device, if I'm diving into the device's mind, right? If I find something that's going on, now I don't just monitor and detect and say, hey, Dan, you've got something going on in your network. I implement a countermeasure that stops it in its tracks. Now, be careful with this one, right? Because the last one I'd like to talk about is something known as unified threat management. And unified threat management, sometimes called, this second one there is just for you guys' benefit. Again, keep in mind we try not just for what's on the exam, but also real world. You might hear it called not only UTM, Unified Threat Management, you might hear it called USM, and that's Unified Security Management. Really no different. All right, but a unified threat management device does all the same things of intrusion detection and intrusion prevention, but it goes a little bit farther. It can implement things like firewall services, anti-gateway or gateway antivirus as well. And that's really what you find today. A lot of times you don't find something that is just an intrusion detection system. You find one that's an intrusion prevention system. Why? Well, they can do both. Well, if I've got an intrusion detection system, why not just have an intrusion prevention system that can also implement some kind of countermeasure? And we find this a lot today. All right, now, here's another one, again, not for the exam, more for your own benefit. If you hear next-gen firewall, right, you might hear it literally NG firewall. That's usually what these devices are today, is an intrusion prevention system, is an intrusion detection system, is a VPN concentrator where it can also do simultaneous VPN communications, as well as firewall services, as well as antivirus gateways, as well as even spam filters and content filters, right? And that essentially is what the UTM device is. Just think about unified threat management. And they go even farther than that too. This is just very generic, right? They get to where they actually connect to the cloud, connect to your cloud-based services, and can become things like your connection security brokers, can find out what's going on across your cloud devices, can integrate with heuristics where they actually contact the vendors' websites and pull down things like definitions and submit samples out there so you can be aware of things like your zero-day threats, which we'll talk about in the security episodes as well. So again, keep in mind what a unified threat management device is. Last one they talk about here, ladies and gentlemen, is one that I really don't have a diagram for. This is something known as legacy and embedded systems. So what's the issue with these network host services? An embedded system, all right? An embedded system are like your SCADA systems, supervisory data acquisition and control system, I believe, SCADA systems, all right? These are devices where a lot of times what you have are what they call SoC, system on a chip. You have everything built into the PCB, the printed circuit board itself. A lot of times they have sensors on them that do active sensing, and they might even accept inputs where you can control certain devices within things like manufacturing as well. Legacy systems. Now, it's interesting because this doesn't really have anything to do with security. Minus the internet appliances that they talk about here, which are the UTM, IPS, and IDS. But you got to be careful with legacy systems because there are systems out there that we need and that you will support that they're not going to upgrade. All right, why? Well, you have devices out there that are maybe specific to a piece of software and it isn't broke, don't fix it. right? We're not going to fix it till it is. Or there's a device on your network that is supporting a piece of software that we've mentioned many times throughout this series that your company wants to get all their money for. Works, right? $100,000 we just spent on this protection system, right? Or maybe not even protection system, but a piece of software out there, and the only device that it really supports it is a Windows XP box, right? Or a Server 2003, which is well past its life cycle. You can't get updates for it. So be careful with these devices. A lot of times what they'll do is they'll do air gap networks on some of these systems so that you don't have to worry about the security vulnerabilities with them. Again, keep in mind embedded systems typically take small resource required or small resource intensive streamlined operating systems, right? A lot of times they're not going to be like a Windows, and there are Windows embedded operating systems out there, but I will tell you a lot of times what they're going to be running is they're going to be running some stripped down form of Linux. Why? Because it's more stable. A lot more that you can do with it, and it runs in a very, very small footprint. Because if I have an embedded system, a lot of times what I don't have is a lot of CPU power, a lot of horsepower, if you will. And if you can download something like Linux to it, and it only runs in like 200 megs of RAM, then you're not really worried about it. So keep in mind embedded systems, and then those legacy systems are the ones where the operating system and maybe even the hardware itself is well past its life cycle, its management life cycle from the vendor. So you can have them. You're probably going to see them, maybe even a few of them. Keep in mind that they're also a security vulnerability because a lot of times the vendors no longer patch them. But you might have to have them in your company. So a lot of different networked host services. One of the last things I'll say, Dan, here is just keep in mind it's the service that the device is providing on your network that defines what its functionality is within that network.
That's good stuff. Wes, we do appreciate you walking us through these different types of servers and services and hosts that we might find networked or connected inside of our environments that we might have to actually support and administrate. People are going to say, hey, this thing's offline and something's not working. What do we got to do? Well, we have to be familiar with what that something is and make sure that we can get it back online so that people can take advantage of it. Wes, thanks for that. We do appreciate you stopping by the studio today. We do thank our good audience for watching. Hopefully you've gotten a lot out of this episode, but it's our time to sign off. That's right. For IT Pro TV, I've been your host, Daniel Lowry.
And I'm Wes Bryan.
And we'll see you next time.
Thank you for watching IT Pro TV.